This is Carlos Cousins, and the following kind of algebra problem is going to require you to see that because p is less than 0, it's negative. So we start out with a negative number times q, negative number here that is going to be multiplied by 2 times q squared, etc., etc. And since q is negative 1, anytime that it's raised to an even power, since a negative times a negative equals a positive, it's going to be basically equal to 1, so negligible. So 2pq squared, for example, will have to be the same thing as 2p, since q squared is negative 1 times negative 1, which is just 1. Same thing with 6pq to the fourth, that's just going to be 6p, since that's just going to be q squared, or 1 times 1, which is just 1. So you're going to end up with 6p. But for the pq and the 4pq cubed, though, the q is actually just going to be a negative 1, so it's going to make the p negative, but p is already negative. So if you're going to make that negative negative, you're pretty much saying that you're going to have a positive p here, and a positive value for p, or eventually, and you're going to end up with, I'm going to actually represent it like this, where this will evaluate to a negative number, the second answer choice, the first to a positive number, the third to a positive number, and the last to a negative number. So since we want the least value, we're going to have to focus on these negative numbers. So I'm going to cross out A and C. Now between B and D, the one that will be more negative is answer choice D, since we have a coefficient of 6 here. Now to give you an example, if that's a little bit confusing, let's pretend that P were equal to negative 5. 2 times negative 5 would give you a negative 10. But 6 times negative 5 would give you a negative 30. So this one is going to have to be the lesser value because it's a more negative number. It's a greater negative number. And the reason I picked negative 5 and I couldn't pick something like positive 5, which would make this not the case, is that p is less than 0. You have to keep that in mind. I hope that helped with this problem, and happy proving.